This is your review for your rational functions test. Question 1 asks you to factor the numerators and denominators and divide and simplify. Remember, whenever you divide fractions that you're multiplying by the reciprocal. So looking at our first numerator, I've got negative 15 multiplies to give me negative 15, adds to give me negative 2. That's going to be a negative 5 and a positive 3. So it factored to be x minus 5 and x plus 3 divided by my numbers that multiply to give me 20 and add to give me negative 9 are a negative 4 and a negative 5. So x minus 4, x minus 5. Over here I'm going to switch these because I'm dividing. So I'm going to look at this one. What multiplies to give me negative 4 and adds to give me negative 3. That's a positive 1 and a negative 4. So I'm going to have x minus 4 over x plus 1. And then this one is going to go on bottom because I'm dividing, so I'm looking at the numbers that multiply to give me negative 3 and add to give me 2, which is going to be a positive 3 and a negative 1. So I'm going to have x minus 3, x plus 3, x minus 1. Go ahead and simplify. And remember, everything that you simplify are numbers x cannot be. So x can't be 5, 4, negative 3. Also, this one that we were originally dividing by and that was in the denominator, x can't equal negative 1. This factor right here can't be equal to 0. So then simplify this as x plus 1 divided by x minus 1, and x can't equal these four numbers. Alright, then we've got a graphing. Find the domain of the function. Remember, the bottom part, the denominator, can't equal 0, so x can't equal 1. So in interval notation, that's going to be from negative infinity to 1 and 1 to infinity. Evaluate at f of 3. That just means to substitute in 3 for x. 3 minus 1 is 2, 2 divided by 2 is 1, 1 plus 3 is 4. From the same problem, we're going to find the horizontal asymptote. That's how much it got moved up. So that's going to be at y equals 3. And the vertical asymptote is what x can't equal. So x is equal to 1. If we're going to draw that, we're going to draw a vertical asymptote and our horizontal asymptote. And then we're going to plot our point that is, and the place we get that is this 2 right here. So from where the asymptotes intersect, I'm going to go over 1 and up 2, and left 1 and down 2. Then I'm going to draw my function. Alright, number 4, given the function in the form with a vertical asymptote at x equals 1, horizontal asymptote at 5, and it passes through the point 3, 1. Write it in this form. So this is my x, this is my y, this is my h, this is my k. I'm going to plug those all in and solve for a. So I'm going to have 1 equals a, which I'm still looking for, over x3 minus h1 plus k, which is 5. So 1 is equal to a divided by 2 plus 5. Then I'm going to subtract 5. Negative 4 is equal to a over 2. Multiply by 2. A is negative 8. So when I write it in this form, I'm going to have f of x equals my a value, which is negative 8, over x, and I'm leaving an x so that I can plug in other values for x, minus my h value 1, plus my k value 5. Then I want to find f of 7. So I'm just going to substitute in 7 for x. So f of 7 is equal to negative 8 divided by 7 minus 1 plus 5. So negative 8 over 6 plus 5 is 3.6 repeating. Solving equations. This is a simple one. I'm just cross multiplying, so I'll have 3 times 3x plus 4 is equal to 2 times 5x minus 7. Distribute, that gives me 9x plus 12 is equal to 10x minus 14. I'm going to subtract 9x and add 14, and I get 26 is equal to x. B, so I'm going to multiply everything by the least common denominator, which in this case is x minus 1, x plus 1. So here my x minus 1's cancel, here my x plus 1's cancel. So this will give me 3x. I'm going to work it right over here so I have a little bit more room. 3x times x plus 1 plus x plus 4 times x minus 1 equals 8 times, and this is a difference of squares, so that's going to end up being x squared minus 1 whenever I multiply that out. Distribute, that gives me 3x plus 3 plus, that's going to be x squared, negative 1, positive 4 is a positive 3x, minus 4 is equal to 8x squared minus 8. Now I'm going to move everything over to one side, so I'm going to subtract 8x squared, and I'm going to subtract 8. This should be a 3x squared, and this should be a 3x, sorry. So 3x squared times x squared is 4x squared, minus 8x squared is negative 4x squared. 3x and 3x is a positive 6x. Negative 4 and positive 8 is a negative 4 and positive 8 is a positive 4 equals 0. These are all divisible by, I'm going to divide them by negative 2. That gives me 2x squared plus 3x, minus 3x minus 2 equals 0. And then I'm looking for the numbers that, because this is a 2, I've got to multiply to give me negative 4, add to give me negative 3. That is a negative 4 and a positive 1. Now I go back through, divide them by 2, reduce if possible. So my factors here are x minus 2 and 2x plus 1. Set my factors equal to 0. So x could be 2, subtract 1, 2x is equal to negative 1, x could be negative 1/2. I can plug either of those in without dividing by 0, so those are both my answers for B. C. Same thing, I'm going to go back through and multiply by my least common denominator, which is x plus 2, x plus 6. So here my x plus 2's cancel, here my x plus 6's cancel. I'm going to get x plus 6 times 2x plus 3. Minus 6 times x plus 2 is equal to x plus 2, x plus 6. That gives me a 2x squared. 3x and 12x gives me 15x. 3 times 6 is 18. Minus 6x minus 12 equals x squared. 6x, 2x gives me 8x plus 12. Now I'm moving everything to one side. So that gives me x squared. 15x minus 6x is 9x, minus 8x is 1x. 18 minus 12 is 6. Minus 12 again is a negative 6. And my numbers that multiply to give me negative 6 and add to give me 1 are a positive 3 and a negative 2. So x can equal negative 3 and positive 2. Alright, our next one, find the vertical asymptote. The vertical asymptote is x is equal to negative 2. That's when the bottom would be 0. Find the vertical asymptote of f of x plus 4. Well, this would move it left 4. And left 4 from negative 2 would be at negative 6. find the x-intercept. The x-intercept happens whenever y is 0. So if 0 is equal to 4x plus 11 over x plus 2, I can multiply by x plus 2 to get rid of my denominator. 0 times anything is 0, so then I have 0 equals 4x plus 11. And I'm solving for x. Subtract 11, which is negative 11 equals 4x, divide by 4. X is equal to negative 11 over 4. So that is negative 11 over 4. 0 is your x-intercept. The y-intercept happens when x is 0. So f of 0 is equal to 4 times 0 plus 11 over 0 plus 2. 11 over 2. So that's going to be at 0, 11 over 2. Use synthetic division or long division to rewrite in this form. I'm going to use long division, so x plus 2, 4x plus 11. X times 4 is 4x. Subtract. That gives me a 3, so I have 3 over x plus 2 plus 4. It's my function. My vertical asymptote is that negative 2. My horizontal asymptote is this 4. Graphing this, so I've got vertical asymptote at negative 2, horizontal asymptote at 4, I've got a point at negative 11 over 4, which is like negative 2.75. That one's a little bit hard to make. I'm going to go ahead and from here, from my point where my asymptotes intersect, I'm going to go over 1 and up 3. And left 1 and down 3. 0, 11 over 2, so that is at 5.5. Then this negative 11 over 4 is going to be right in there. So this is my graph. Would the inverse be a function? Yes. It passes the horizontal line test. Remember the horizontal lines test says that no y values repeat. The function is given by this. Use synthetic division or long division to show that it can be rewritten this way. So you're just setting up long division. You have your answers there to double check. Then change your signs. That is 7. 7 it goes on top. X minus 3 plus 2. That's all you have to do there. Find the equation for the horizontal asymptote. The horizontal asymptote is y equals 2. Vertical asymptote is x equals 3. Write the coordinates where the asymptotes intersect. Well, I've got a vertical line at 3, a horizontal line at 2. That's going to be the point 3, 2.